Chapter 7 is about chemical reactions. When substances combine, there is a change that occurs, but that change can be physical or it can be chemical. If you take sugar and salt and mix them together, they are mixed up, right? But there's not been a chemical change, it's a physical change, which reminds me of the year when I was making pumpkin pies for Thanksgiving. And my 2-year-old Michael, he was 2 at the time, he's not 2 anymore, was helping me. And unbeknownst to me, he put a whole bunch of salt in the flour canister. And so the first batch of pies was fine. The second batch, I tasted the crust and I had to spit it out. It was so nasty. And I finally figured out that he had put salt in the flour canister. So that is a change to the flour. But the flour and the salt were still the same. It's just that they were mixed together. So when something gets mixed up, it's a physical change. A chemical change involves the particles, the actual substances changing. And so we're going to talk about chemical changes. We call those chemical reactions. It's just a different name for a chemical change. There are times when you can't tell if a chemical change has occurred or not, but a lot of times there are hints or clues, and so we're going to look at those. The first evidence or clue that a chemical change has occurred is that a gas is produced. And this may be observed as bubbles or fizzing. Bubbles or fizzing. So the picture here looks like they've put Alka-Seltzer. I'm not sure exactly what they put in this flask, but you see there's bubbling and fizzing. You mix baking soda with vinegar and it fizzes, right? That fizzing is because a gas is being released. Now, these evidences are not absolute proof that a chemical change has occurred, because what happens when you put a pot of water on the stove and you turn it on? It boils, right? What's happening when it's boiling? It's producing a gas. So we do have to think about it a little bit, because what's happening when you boil water, that's a state change. You're going from a liquid to a gas, and that's not a chemical change. The water molecules are remaining the same. So anytime there's a state change involved, it's a physical change. But other than that, if you see bubbles or fizzing, it's a chemical change. Another clue is that we get an insoluble solid produced in a solution. We can dissolve substances in water to form aqueous solutions. We've talked about that a little bit, but an aqueous solution just means that something's dissolved in water. You put a teaspoon of salt into a glass of water and stir it, and it seems to disappear, right? It dissolves in the water, and then the water is salty all over, right? That's an aqueous solution. Sometimes when you take 2 aqueous solutions and mix them together, you get a solid that forms that wasn't there before. That means something happened. There was a chemical change, a chemical reaction. We call that solid a precipitate. So the weatherman, when he talks about precipitation, what does he mean? Rain, snow, sleet, hail, something coming down from the sky, right? Here we have a picture of one clear solution, colorless solution, being added to another colorless solution, and we see this bright yellow, cloudy substance being formed. This one doesn't look like snow, but some precipitates actually look like it's snowing. You see these little flaky white things falling to the bottom. The fact that we cannot see through this tells us that it's a precipitate. A solid is being formed. The particles are very, very small, and if we wait, they will all settle to the bottom. So that's an insoluble solid forming. Another observation we may see is a permanent color change. Now here we're seeing a color change and a precipitate. But sometimes you can take 2 colorless solutions and mix them together and they will turn bright pink. Still clear, you can still see through it. That tells you that it's a color change but not a precipitate. A precipitate, you either see the solid or the solution becomes cloudy or milky and you can't see through it anymore. That's because there are very tiny particles but they're much larger than the molecules, and they obstruct the light from going through. So permanent color change. Sometimes we use a special chemical called an indicator to help us follow a reaction that might otherwise be invisible, and this happens with acid-base neutralization reactions. If you mix sodium hydroxide and hydrochloric acid, they're both colorless solutions. You mix them together, you still have a colorless solution. There's a chemical change that occurred, though. And if you use an indicator like phenolphthalein, the phenolphthalein will change color because of the chemical reaction between the other two. And the last piece of evidence is an energy change. Chemical reactions always involve an energy change, but sometimes it's too subtle for us to notice just with our five senses. Heat and light are two forms of energy, and those are the two that we're most likely to observe. We have terms for these reactions: exothermic and endothermic. And here those prefixes have significance. So exo reminds me of the exit sign. An exit means you go out, right? Exothermic, thermic refers to heat energy. So that means that heat energy is going out of the reaction. It's releasing heat energy. When you light the gas barbecue in the backyard, there's a chemical reaction occurring as the propane burns. That's an exothermic reaction. It gives off a lot of heat. There are also endothermic reactions. Endo, so this is like exit, and endo reminds me of the word into. These are reactions that heat goes into. And we don't run across those as much, but have you seen those instant cold packs? The athletic trainer might have one on the sidelines in case someone gets hurt and needs a cold pack and they don't have any ice. You break open some little packet inside and you squish it around and it gets cold all by itself. It seems like magic, doesn't it? Like, wow, how'd they do that? It's an exothermic reaction, and it sucks heat in from the outside. As it sucks heat in, it makes the pack cold. And so that's an endothermic reaction. So if we mix some things and it gets warm or it gets cold, that tells us there's been a chemical reaction that has occurred. Light is another form of energy. In this reaction here, which I think this is potassium in water, we see some sparks flying, and we see some flame, and light is being given off. So that tells us that a chemical change has occurred. Glow sticks. I mean, is there anybody who doesn't like those light sticks that they sell at the dollar store? They're just neat. My kids are obsessed with them. They're like, can we get more glow sticks? A friend of mine actually built a glow stick launcher using an air tank and a long piece of PVC pipe. It's really fun. You load that pipe up with the big fat glow sticks, and you release the pressure on the tank, and they shoot into the air, and it almost looks like fireworks. And then the kids run all over the place and pick them up, and they do it all over again. Then they get really nice and tired, and they fall asleep on the way home. It's awesome. But the glow sticks, it's a chemical reaction. It's releasing light energy. It makes that crinkly, crunchy sound as the little glass tube inside breaks, and then it starts to glow. It releases energy. Does it keep doing that forever? No. It lasts for a few hours, and then it slowly fades away because the reactants get used up. You can make your glow stick last longer, like if you play with it for an hour in the evening, and then mom makes you go to bed. Obviously, mom doesn't make you go to bed, but my kids are like, no, you got to go to bed now. No, you may not sleep with your glow stick. Put it in the freezer. If you put it in the freezer, cold temperatures slow down most reactions, and you can pull it out the next day. Probably wait till night when it's more fun, right? Pull it out, and when it warms up, the reaction resumes, and it'll glow again. So there's a tip for you. So those are the evidences for reaction. So let's look at these descriptions and identify what's the evidence for each of these. We mix two solutions and we see a temperature increase. What is the significant thing to notice about that? The temperature increase. So a temperature increase, that means that there's an energy change. Pouring vinegar on baking soda gives foamy bubbles. Gas is being released. We're seeing bubbles. Sometimes you may not observe bubbles, but there's a new smell. A new smell can be the release of a gas as well. Mixing two solutions produces insoluble particles. That's the precipitate, a solid forms. I'll try to be consistent here. Solid forms. Mixing two colorless solutions gives a yellow solution. Color change. So when we observe any of those four things, then we can be pretty sure that it's a chemical change. Any questions?